Hello class, this is Aligani, and today we're going to be looking at uh, problem 2 to 6 in packing and circuit switching. Okay, for problem 2, this will be the usual equation. In the question asking us, is asking equation 1.1 gives a formula for the end-to-end delay of sending one packet of n length L over n length or transmission rate R. Generalize this formula for sending P such packet back to back on the n lengths. Okay, what this equation is asking us is they're already giving us the information. R will be the transmission rate, N will be the total number of lengths, L will be the packet length, and P will be the packets. So usually an equation would be like end-to-end delay. So then here would be like D end-to-end. However, they're asking us to generate a formula for sending P such packet back to back over the end. Well, now what that means is back to back. It will be like how many times you can send the packet from the links. So then the equation would be here. It asking us the following formula for the back-to-back delay of sending P packets of each of length L over n lengths of transmission rate R would be D back-to-back equal Pn parentheses L over R. Now we go to the question. Consider an application that transmits data at a steady rate. For example, the sender generates an n-bit unit of data every k time unit, where k is small and fixed. Although when such an application starts, it will continue running for a relatively long period of time. Answer the following question, briefly justify yes. So this question has two parts in poverty. Will a packet switch network or a circuit switch network be more appropriate for this application, and why? So considering on the problem that we read here in the circuit switch, my best bet would be a circuit switch network. Why, you may ask? Because circuit switching allows data to be transmitted more from a reserved route. So what usually means is only two devices can be used on this reserved route. You gotta choose the connection. Because for a route or the link, usually there'll be more than one route. However, the computer in a circuit switching network, you need to, like for the client, the computer, you need to choose a reserved route, and there you need to establish the connection. So usually only two computers can use it, not more than two. Okay, and let me explain more. Because the bandwidth is also being fixed, which what you may asking? Well, the bandwidth being fixed is depending on like the amount of data that you're using. Like if you're sending a PDF that will be coming from the computer that uses 10 data bits per second, the other one uses 6 data bits per second. Now, the computer with the 6 data bits will not get the full package, the full PDF or package from the other computer, because some of that data might be lost, and that will be leading to bandwidth wasted. There will be bandwidth wasted will be based on the number of times bandwidth being unused. This will be the concept, because you cannot reclaim those bandwidths, because those bandwidths are going to be gone. You cannot reclaim them back. And it also is not very time efficient, since how should I say, the packets, they don't usually come in order in circuit switching. Now, however, there is also some problem with circuit switching, because circuit switching is not usually time efficient space, since there will be long phases involved. Like you need to choose the route, which is establishing the connection, and closing the route, which is also a listening connection so that no other computer can use it. So basically, it's like roadwork. For a car to want to go to Highway 59, and they close Highway 59 because they're doing construction, and they gotta make sure no car have to use this highway. So basically, you gotta send the other car to another highway, so like that. Okay, now suppose that packet switching is used and the only traffic in this network comes from the applications described above. Again, furthermore, some of the application data rates is less than the capacity each and every. Would there be some form of congestion control needed? And why? Okay, as we read this, now packet switching is a bit different from circuit switching, because in packet switching, the packets take the data divided into packets. And if you're getting confused, hold on. And for circuit switching, it's just that the data is all mashed up. They're not divided. Like, oh, we had this one large file of essays. The essay is going to be divided into packets. While for circuit switching, all that data is going to be pushing all mashed up together. Okay. And these packets in packet switching is that they choose wherever they're going in the route. So in packet switching, there would be more than one route for the packets. Okay, now why? Because if the route that they choose, like the first one, is congested or damaged, the packet choose another route to get to the destination, which is the other computer. Now this effect helps to complete the task of the application, would be the packet going over the destination from the bandwidth, which is sufficient. Problem 4. Considering circuit switch network in figure 1.13, recall that there are 4 circuits of each link. Label the 4 switches A, B, C, and D going the clockwise rotation. Okay, now what you need to do here is basically you need to go into your textbook and look up figure 1.13. There, you need to draw right letter A, B, C, and D in your textbook, like going clockwise direction, which I did for in this question. Now, first question: what is the maximum number of stimulus connections that can be employed at any one time in this network? Okay, so bear with me. Okay, so the number of connections that can be in progress will be 4 connections from the upper and lower links. So basically that would be like the upper and lower corners, like from upper right to the upper left to left to the lower right. Okay, now each of those 4 connections will make up a total of 16 connections, basically. And 16 connection is your total of the maximum number of simultaneous connections that can be in progress. So consider it like this: 4 times 4 equals 16, basically, I believe. Okay, now let's go to part B. Suppose that all connections are between switches A and C. What the maximum number of simultaneous connections that can be the same thing? But however, you gotta know one thing. A asking the maximum number, like all of the circuits. And in here, they're asking from switches A and C. So, shall we? Okay, now from switches A and C, which you could say, now the switches, like all the switches A, B, C, and D, they're all circuits. Now, let's continue. Now, from between A and C, there will be 4 switches passing through in the upper right-hand corner, which will be like where A is. And hold on. Sorry, background noise. Now, what we were saying? Ah, yes. Now, this is going clockwise direction, and I said that A would be the circuit A would be the right, and circuit B would be the left. And you're asking me why? Well, because if we were going counterclockwise, let's say in the picture, then then B would have been right, and A would have been your left. But right now we're going clockwise, so I know some of you are really confused, but bear with me. Okay, so it will be in the upper right hand corner again, which will be the upper links. And then you will have another 4 connection passing through the lower left hand corner. Okay, the lower left hand corner will be around D. Which if you know, if you make these 4 connections, now these are in progress. Now the total will be 8 connections. Now that will be the total. So in first one we were like multiplying of the 4 connection based on how do you do, because it's not gonna be so. In this one we're adding like 4 plus 4 equals 8. Okay. And based on the textbook that you see here and your drawing, you're connecting the circuit based on where they go. Because it would not be on the same wood. It would not. If let's say for A, and I want to go to circuit, circuit. Wait, left hand corner. Sorry, if you're confused, D is the lower right hand. C is the lower left hand. Circuit C, the lower left hand corner. Okay. Now if you want to get to circuit C, now you have circuit A going to circuit B, and then circuit B go to circuit C. However, instead of using that same route, circuit A can also go to circuit D and then do circuit C. Basically. Okay. Now instead of getting off time, we should continue. Suppose we want to make 4 connections between switches A and C, and another 4 connections between switches B and D. Can we route these cores to the following to accommodate all 8 connections? And the truth is, yes, you can. You can route these cores to accommodate all the 8 connections by allowing the connection from switches A and C. Since you could route 2 connections to circuit B and 2 connections to circuit D. Now for circuits B and D. Okay. Now, while for a connection between circuit B and D or switches B and D, you can route 2 connections to A and 2 connections to C. Basically, you can have 2 connections. Now, these 2 connections will make about 4 connections, passing through the upper and lower links. So far, if you have the textbook down and you're looking at it and you're drawing with your own finger, like where they connect, that's gonna help you understand it. So for students who don't have the textbook, I recommend that you borrow a textbook from your classmates, or also buy one for yourself. But most normally ask someone to give you a textbook if you're like for borrowing, like on the notes. And also, if you're a bit confused, you can also look up at the video that the professor left us in the course website. Now, let's go to the final problem, number 6. Now, 6, that's going to be a bit tricky. Okay, for number 6, from what I understand is, this elementary problem begins to explore propagation delay and transmission delay, which these are 2 central concepts in the data network, and they can also be found in the textbook, considering 2 hosts, A and B, connected by a single link of rate RBPS. Bits per second, I suppose. Suppose that the 2 hosts are separated by m meters, and suppose the propagation speed along the link is s meters / second. Host A to send a packet of L bit to host B. Now, explore the propagation delay, dprop in terms of M and S. Okay, now here